Hello class 12. Today we are going to discuss about conductance. So, conductors are those substances which conduct electricity. So, when we say conductor, we say those substances which conduct electricity or which allow the electricity to pass through it. Now, conductors are divided into two categories. One is called electronic or metallic conductors. Electronic or metallic conductors are those conductors which allow the electricity to pass through them without dissociating into ions. Generally, metallic conductor contains large number of free electrons, and due to the movement of those free electrons, current passes. They do not get ionized. So, we say electronic or metallic conductors, they conduct electricity due to the presence of free electrons. Do not ionize. Means they do not form ions. Whereas the second type is called electrolytic conductors. Electrolytic conductors are those which conduct electricity due to the movement of ions. So, electrolytic conductors, they conduct electricity only when they have ions. So, due to the presence of ions, or we say due to the movement of ions from one place to another place, electrolytic conductors, they conduct electricity. So, now we have to keep in mind that electrolytic conductors, they always conduct electricity due to ions. Whereas metallic conductor, they conduct electricity due to the movement of free electrons. Now, what is ionization constant? We know that strong electrolytes are those which ionize completely or which dissociate into ions completely, whereas weak electrolyte do not dissociate completely into ions. So, we have another concept, that is degree of ionization. Degree of ionization is simply defined as number of molecules get ionized divided by total number of molecules. Greater the degree of ionization, greater is the electrical conductivity of the electrolytic solution. Now, we are going to discuss the factors which affect electrolytic conduction as well as the factors which affect metallic conductors. So now we are going to discuss about the factors which affect the electrolytic conduction. So we have to keep in mind there are 5 factors which affect electrolytic conduction. First is nature of the electrolyte. We know that strong electrolytes are those which dissociate completely into ions. So, greater the number of ions, greater is the electrolytic conduction. It means nature of the electrolyte, it affects the electrolytic conduction. So, stronger electrolyte, greater is the electrolytic conduction, whereas weaker electrolyte, lesser is the electrolytic conduction, because electrolytic conduction depends upon number of ions. Now, let's move towards the second, size of the ions and their solvation. Solvation means combination of solute, molecules or solute ions with the solvent. So, size of the ions, they plays a vital role in electrolytic conduction. Greater the size of the ion, lesser is its movement. It moves slowly, hence lesser is the conductance. Similarly, solvation, greater the solvation, lesser is the conductance, because the molecule, the ions, they get attached with the solvent molecules to form a bigger molecule. So we say molar conductance, so we say electrolytic conductance, that is inversely proportional to size of ions or inversely proportional to solvation. Greater the solvation of the ions, lesser is the electrolytic conductance. Similarly, if the ions are of bigger size, they move slowly, hence electrolytic conductance decreases. So electrolytic conductance is inversely proportional to size of the ions, inversely proportional to the solvation of ions. We write here solvation of ions. Now, the third factor, nature of the solvent and its viscosity. It has been found that those solvents which are more viscous, they have lesser electrolytic conductance. They do not conduct electricity to the large extent. Again, the polar solvents, they conduct electricity to the large extent because like dissolve like. So, in case of polar solvents, the ions, they dissociate easily and hence they move from one place to another place easily. It means polar solvents, they have greater electrolytic conductance, and electrolytic conductance is inversely proportional to viscosity. More viscous is the solvent, lesser is the electrolytic conduction. This is the third factor. Now the fourth, concentration of solution. As the number of ions per unit volume increases, if we increase the concentration of the solution, it has been found that the electrolytic conductance, it decreases. It means electrolytic conductance is inversely proportional to concentration of solution. Greater the concentration of the solution, lesser is the electrolytic conductance, and last is temperature. Of course, degree of dissociation, it increases with rising temperature. It means electrolytic conductance is directly proportional to temperature. As temperature increases, more and more molecules, they get dissociated into ions, as the result of which the electrolytic conductance increases. Now, these are the 5 factors which we have seen for electrolytic conductance. Now let us see the factors which affect metallic conductance. Keep in mind, metallic conductance is only due to the movement of ions. As temperature increases, keep in mind, for metallic conductance, temperature increases, their metallic conductance decreases. Now for the metallic or electronic conductance, we can see that there are 3 factors which are responsible. One is nature and structure of the metal. Metals which contains large number of free electrons like copper, aluminium, they are good conductor of electricity. Second, it also depends upon number of valence electrons per atom. Greater the number of valence electron per atom, it means larger the free electrons, greater is the electronic or metallic conductance. And temperature. Keep in mind that metallic conductance is inversely proportional to temperature, because the number of collisions per unit volume increases when temperature increases. Now we are moving towards another topic, that is electrical resistance and conductance. We all know that according to Ohm's law that we have read in class 10, Ohm's law simply states that V is directly proportional to I. where V is called voltage or potential and I is called current. V is equal to IR, where I is known as current and R is resistance. R is equal to V upon I. R is the resistance offered by a body to the flow of current. The SI unit of R is ohm. That is represented with omega. So 1 ohm is equal to 1 volt upon 1 ampere. So 1 ohm equal to volt per ampere. That is from Ohm's law. Now we also know that resistance R depends upon length as well as area of cross section. So R is directly proportional to and inversely proportional to A. So R is equal to rho L upon A, where rho is called resistivity or specific resistance. So when we take the reciprocal, keep in mind the reciprocal of resistance is known as conductance. So 1 upon R is equal to 1 upon rho into, it comes A upon L. 1 upon R is called conductance. 1 upon rho is known as conductivity. So this one can also be written as G is equal to kappa into 1 upon G star. So kappa is equal to G into G star. Keep in mind this K is known as kappa. Kappa is known as conductivity. Kappa is conductivity. And G is called conductance. G is reciprocal of R. And here you can see G star. This G star is called cell constant. And the value of G star is L upon A. Keep in mind, sometime it comes in exam, what is cell constant. So we must know the value of cell constant. Cell constant is equal to L upon A, whose SI unit is per centimeter. So we can see here that a relation K, that is kappa. So kappa equal to G into G star. Keep in mind G is conductance and G star is called cell constant. And what is kappa? Conductivity. So kappa is equal to 1 upon rho, G is equal to 1 upon R, and G star is equal to L upon A. Very, very important concept. This is conductivity is also known as specific conductance. Now we are moving towards another very, very important concept, that is, let's first define conductivity. What is conductivity? Conductivity is simply defined as conductance of a solution of 1 centimeter length having an area of 1 centimeter square as area of cross section is called conductivity. So when it comes in exam, what is the meaning of conductivity? We simply define conductivity is simply defined as the conductance of a solution of length 1 centimeter having area of cross section 1 centimeter square. Because we know 1 kappa is equal to 1 upon rho. And what is the value of rho? Since R is equal to rho L upon A, so 1 upon R is equal to 1 upon rho into A. Here comes A upon L. So 1 upon rho is equals to, when we cross multiply, it comes 1 upon R into L upon A. 1 upon R is called conductance. That is why we are saying that kappa, that is conductance of a solution, conductivity is equal to the conductance. 1 upon R is conductance. Conductance of a solution having 1 centimeter length and area of cross section is 1 centimeter square. Keep in mind these length. This is the length of the electrodes, and the area of cross section means area between the two electrodes in which the electrolysis is being carried out. So the unit, as a unit of kappa, is per ohm per centimeter or Simon per centimeter. Simon is a reciprocal of ohm. So ohm inverse is also equal to Simon. So Simon per centimeter. This is the definition of conductivity or specific conductivity. Now we have a very interesting factor, that is equivalent conductivity. What is this equivalent conductivity? Equivalent conductivity is simply defined as the conductance of all the ions produced when 1 gram equivalent of an electrolyte dissociate completely into its ions in V centimeter cube of the volume, provided the length of the electrodes is 1 centimeter and the area is so large that whole of the electrolyte is contained between them. So lambda equivalent is equal to kappa into 1000 upon C equivalent. C equivalent means normality. This is the relation between equivalent conductivity and conductivity, that is kappa. So keep in mind the definition of equivalent conductivity, that is the conductance of all the ions we write here. Equivalent conductivity is the conductance of all the ions produced when 1 gram equivalent of electrolyte dissociate completely in V centimeter cube of solution, provided the length of electrodes is 1 centimeter and the area is so large that the whole solution is contained between the electrodes. So this is the definition. So lambda equivalent equal to kappa into 1000 upon C equivalent. C equivalent can also be written as normality. SI unit of lambda equivalent is Simon per centimeter square per equivalent or Simon per meter square per equivalent. Now, after doing the equivalent conductivity, the next concept we have, that is molar conductivity. Same definition there is slight change. The conductance of all the ions produced when 1 mole, instead of writing 1 gram equivalent, we say when 1 mole of the electrolyte dissociate completely in V centimeter cube of the solution, provided length of each electrode is 1 centimeter and the area is so large that whole of the electrolyte is contained in the electrodes. Here, instead of writing C equivalent, we write concentration and we write here M. So here comes molarity. SI unit will be Simon centimeter square per mole or Simon per meter square per mole. That is the SI unit of lambda m. Keep in mind, lambda m is called molar conductivity, the conductance of all the ions produced when the electron, when 1 mole of the electrolyte dissociate completely into ions. So tomorrow we will discuss some more factors. We will discuss the effect of temperature on molar conductivity as well as conductivity, and we will discuss few numericals based on these formulas. Till the time, just revise, go through your books, and if you find difficulties, ask us. Thank you. Thank you very much.